This implies that reality is something created by the observer. That is, reality is we have what we call observer-created reality. And this implication has become subject of many interesting philosophical discussions as well as obviously center of many major controversies. Next, I would like to draw your attention to the results of another important experiment. In this experiment, a property of light called direction of polarization is measured. It has been discovered that when a beam of light passes through a certain device, the direction of polarization of the emerging beam is randomly oriented. Several attempts have been made using various models to predict the direction of polarization of the emerging beam. But so far, no single model has been successful in predicting this direction. This random is not confined only to the polarization of light. It can be seen in many other atomic phenomena such as radioactive decay. It should be noted that this randomness is different from the randomness that we talk of in relation to the chance of getting a certain number when a dice is thrown. In fact, in principle, one can build a chain of reasons to explain why we get a certain number face up when we throw a dice. You can construct a mental picture of how it happens by looking at sequence at the way you hold the dice, throw the dice, and the way it rolls on the ground and stops depending on the frictional forces between the ground and the dice. Since we do not know with precision details of each of these steps, we cannot predict the number that will appear face up when the dice is thrown. The randomness arises as a result of this ignorance. Subjectively, we do not have sufficient knowledge of each step, and therefore this ignorance is seen as randomness and is called subjective randomness. It arises as a result of the ignorance of the person who is performing the experiment. But the randomness that we talk of in relation to polarization direction is not subject to randomness. It is a case of objective randomness. After several decades of careful and comprehensive experimentation, quantum physicists are today convinced that randomness seen in relation to the polarization direction of light is a fundamental property of nature. This result has far-reaching consequences that makes us to completely change our view of nature. If randomness is inherent property of nature, then it implies that in relation to light or micromatter, nature does not obey causality or the idea that every effect is causally determined. That means in microworld of micromatter, things are happening without a cause. There can be effects, there won't be causes. However, in classical physics, where we deal with large or macro bodies, causality is well preserved. Another interesting finding with extremely important philosophical implications is a phenomenon known as non-locality of entanglement. This idea was first introduced through a famous paradox in physics called EPR paradox or Einstein-Russell paradox. I shall explain this again in relation to light particles which we call photons. Consider a process by which pairs of photons going in opposite directions is produced. Without going into too much of technical detail, I would like to make the point that two photons of a given pair have same properties in relation to their direction of polarization. What is important to realize is that measurement of the property of one photon affects the results of the measurement of the other. It appears as if the results of the measurement of one photon has been instantaneously transmitted or communicated to the other. This happens irrespective of the distance. This happens in no time. As this happens in no time, it contradicts the Einstein principle of relativity. According to the theory of relativity, no information can pass through space at a speed faster than that of light. I would like to further explain this with the help of a simple example. Let us consider two friends who go to two distant planets, each carrying each taking a dice with them. While there, each person throws the dice in a completely random manner. The surprising fact is that both get the same number face up in whatever manner they throw the dice. They get the same number irrespective of the way they throw the dice. They are in two different planets, maybe far away from each other. This phenomenon is described as non-locality, non-local connectedness or entanglement between two particles. It happens quite independent of the distance between two particles. The two particles seem to behave as one system even if separated by a large distance. Even though they are physically separated by a large distance, they are in fact not separated in a deeper sense. The idea of entanglement can be extended to several particles, and it may be even possible that the entire universe is internally entangled. An important question related to entanglement is that how it would be broken. There is a group of scientists who believe that when one of the particles is detected or observed, the entanglement is broken. There is another group who believe that detection is not a form of disentanglement, but an enhancement of entanglement with additional complex system, the detector. According to them, detection only increases the scope of entanglement rather than breaking. In classical physics, we assume that it is possible to isolate a certain part of the world and study as a separate entity or separate part. This is not always possible. If we were to study a ripples generated in a tranquil pond by dropping a pebble, we cannot take the ripples out of the pond and study them. We have to consider ripples as a part of the pond. Physicists and mathematicians may study them by solving the relevant hydrodynamical equations using boundary conditions which are properties of the entire pond. There is no meaning to ripples as a thing itself. Ripples is of the pond and not a thing in the pond. To understand the ripples, we have to understand the entire pond. The idea that we cannot isolate something from the environment and study it is known as Buddhism. Even though this is something new in science, it has been well established fact in several Eastern religions such as Buddhism, Brahmanism and Taoism. The idea of Buddhism also occupies an important role in quantum mechanics. According to quantum mechanics, it is not meaningful to separate out and study micromatter, and in fact it is not possible to do so. When we observe micromatter, that is electrons, protons, molecules, etc., we have to use an apparatus. Without apparatus, we cannot observe it. We do not have a micro-level apparatus, but only large-scale or what we call macro apparatus. It is important to realize that we are not measuring the properties of micromatter. Though we say so, though we think that we are measuring properties of micromatter, we are not doing that. What we do is we are in fact analyzing the interaction between, we are in fact studying the interaction of micromatter with the macro apparatus. If I may use a modified version of Taoist metaphor to illustrate this, the person who wants to measure the size of fish living in the pond and catch them for this purpose using a net will end up measuring the properties of some fish living in the pond as well as the property of the net. The instrument that we use, to catch the fish defines this conception of fish, and therefore the measurement is instrumentalized in the wrong way. This measurement does not reflect the reality. It only provides details of interaction between the fish and the net. So there is inseparability of the measuring apparatus and the measured matter. Another important aspect of quantum mechanics is indeterminism. Classical mechanics is deterministic. If we know the initial conditions of a system, then we can at least theoretically determine the state of the system in the future, at least in theory. In quantum mechanics, where we deal with micromatter, we cannot exactly predict what could happen in the future. We can only talk of the future behavior in terms of cognitive functions. We can't find numbers, but we can find probabilities only. The indeterminism can be described using simple examples. We use light or any other form of radiation to observe micromatter. As discussed earlier, radiation consists of particles called photons. Shining of light on micromatter is equivalent to bombarding of DC micromatter with photons. This results in change in the state of the micromatter. As the measurement itself takes what we are measuring, it will never be possible to completely understand the nature of micromatter. There is a natural limit to the accuracy with which we can probe a system explained by so-called Wijewardena uncertainties. As mentioned earlier, most successful thing that has been formulated to cope with the world characterized by above features is quantum mechanics. Quantum mechanics is highly abstract theory, and it cannot be applied to the real world unless we have an interpretation. Several interpretations of quantum mechanics are available. Perhaps the most successful interpretation was formulated by Bohr, Heisenberg and others, and this interpretation is known as the Copenhagen interpretation. This interpretation was based on the positive spin. Only phenomena that can be observed exist, but you can observe only exist. And therefore it is meaningless to talk of phenomena that cannot be observed. This again is connected with the idea that reality is created by the observer. However, this idea was strongly opposed by another group of celebrated scientists and philosophers including Einstein, Schrödinger and Karl Popper, who identified themselves as realists. Absurdity of observer-created reality was highlighted by a paradox known as the cat paradox presented by Schrödinger. According to this paradox, an observer-created reality leads to the bizarre situation that, under certain conditions, it is possible for a cat to be dead and alive at the same time. An essay or presentation on modern developments in science is incomplete without making reference to Einstein's theory of relativity. Theory of relativity radically changed our notion of space and time. Time, which was considered to be absolute in classical physics, now depends on the relative speed of the observer. Time is not anymore absolute, it depends on the speed of the observer. Space, which also considered absolute, now has a geometrical structure which depends on the physical material occupied. Masses in the space are deforming the space. Gravitational force that we are familiar since the Newton's historical encounter with the apple is now described as a mere manifestation of the curvature of the space-time continuum. All these consequences of theory of relativity also illustrate the holism of nature and its complexity and the difficulty of understanding through mere observations or mere measurements. What we have been discussing so far paints a very gloomy picture of our understanding of nature. The subatomic particle is both a particle of matter and a wave. The very act of measurement changes the state of quantum event. Heisenberg's principle of uncertainty prescribed a limit to the knowledge of properties of subatomic world that was accessible to man. The uncertainty was not due to any deficiency in the method or instrument of measurement. It was inherent. It was a fact of life. The whole cause and effect paradigm simply did not work in the microcosmic world. The particle was here, the particle was there, particle could be everywhere at a given moment of time. It can be at so many places at the same time. All that theory could predict and predict very accurately was the probability of particle being at a certain specified time at a given or specified place. The whole deterministic world being that was so dear to classical physicists and even to Einstein was threatened, almost demolished. It appears there is no objective reality, or we could never be able to grasp it, even if it exists. We are not much different from the chain slaves in the Plato's metaphor of the cave. According to the metaphor, a group of slaves are chained to the ground so that they can only see the wall of the cave in front of them. There is a fire in front of the entrance to the cave, and the slaves can only see the shadows of the wall of what is happening outside, and hear only the echoes of noise that are made outside the cave. For the slaves who are completely unaware of what is happening outside, the cave shadows and the echoes are very released. Will the slaves ever be able to break the shackles and come out of the cave and understand what is happening outside the cave? According to this lesson that we can learn from this cave, knowledge that comes from the West alone will not help us to break the shackles of ignorance. It is also worthwhile to explore the possibility of utilizing non-Western sources of knowledge to get greater insight into the problems of understanding ultimate truth of nature. It has been speculated that the Eastern thinking has permeated the early development of quantum mechanics. As one of the proponents of this new theory, Irving Schrödinger was a great Sanskrit scholar and a careful reader of Bhagavad-gita. Now there is a tendency among Western scientists to turn towards Eastern philosophies such as Buddhist philosophy in search of added intellectual tool in the development of new theories to understand the ultimate nature, truth of the ultimate nature. It may be possible to give a better interpretation of quantum mechanics by adopting fourfold Buddhist logic of Nagarjuna, as this type of logic is much more suitable to deal with dynamic processes as against the conventional twofold logic of Aristotle, which is only suitable for static processes. A deeper philosophical analysis of Buddhism will reveal emptiness in reality. Buddhism adopts a more fluid and phenomenological view of reality. Reality is considered as a series of momentary phenomenal events. These phenomenal events do not originate in the external world alone, but rather are contingent on complex nexus that includes mind. Buddhist philosophy is full of instances where inquiries are being made into nature of matter and nature of mind. New vistas of thinking that can be opened through the wisdom of Buddhist philosophy may be useful to modern scientists to initiate the third revolution of science. This will hopefully help the slaves of Plato's metaphor of the cave to break the shackles and come out of the cave and see the reality. Even if they come out of the cave, there is a possibility that they will find themselves now inside a bigger cave and the reality may lie outside the cave. With that comment, ladies and gentlemen, let me conclude my presentation. Let me like to thank the organizers once again for the minutes of training and for all of you for your dedication.
Thank you, Professor Tantrigoda, for so lucidly explaining the modern development in science and their philosophical implications. Now we come to the third aspect of the triad under discussion today, that of development. I think the Chancellor and the Chief Guest have both referred to this aspect, but in this symposium, for this task, we have invited a very distinguished personage, Mr. W. Wijewardena, former Deputy Governor of the Central Bank, whom again I am very proud to say is a distinguished alumnus of this university and has been a member of our extended faculty for a very long time. Sure. He will be talking about development in the perspective of Buddhism and science.
Reverend Sir, Chair of the session and resource person, Vice Chancellor, Deans, Senior Professors, members of the faculty and ladies and gentlemen. Like Dr. P. Anand, for me also coming back to Wijewardena is like coming home. Because whatever the professional achievements I have made in my life, the foundation was laid by the Institute of Ceylon, at which I studied about 40 years ago. Therefore, I am eternally grateful to this institution. And when Dr. Sampath Amaratunga asked me whether I could accept an invitation to come and talk to you, I was more than happy to accept the invitation. The topic that was given to me is to analyze the current context of development in terms of Buddhism and science. And we know in the previous sessions, our Venerable Vice Chancellor and also our Vice Chancellor, Dr. Wijewardena, all of them took us through the Buddhist systems and the philosophy of Buddhism. And Professor Tantrigoda took us through the evolution of science. So I don't want to talk on those aspects, but I talk about the implications of Buddhism and science for development. Now, if we look at the human being is no one but a person who has a unique feature that he has a desire to progress. This kind of a feature you don't find in any other species. It's only the human being that you can find. The progress will cover various aspects, and those aspects are human beings want to acquire and enjoy material benefits. They want to develop their intellect. They want to attain spiritual perfection. They want to love and be loved by others, and they want to respect and be respected by others. Now those are the basic aspirations which we have as human beings. And the society in which we live will have to give us opportunities to develop all those things. And when we listen to Chancellor, Professor Venerable Wijewardena and also Dr. Wijewardena, we were told that the basic objective of Buddhism is to develop a being, develop a human being. And Vice Chancellor also told us, if you follow the Buddhist principles, you can develop yourself. So therefore, there is no any disagreement between what the economists call development today and what the Buddhism has taught us. Both want to develop individuals. By developing individuals, both want to develop a perfect person. And the purpose of the society is to first develop the individual, and through the development of the individual, we have to develop the society. So it is from individual to the society, which the economists call, using a funny name called, from micro to macro, from microeconomics to macroeconomics. The same thing has been taught by Buddha also in one of the sutras. He had referred to the fact that if anybody wants to know the universe, all he has to do is to study the human body, which is just only 1 fathom long. Because in the 1 fathom long human body, you will find everything that you find in the universe. Therefore, a simple individual is simply a smaller micro aspect of the whole society, and when we develop individual, we are developing the whole society as such. So the modern day economists therefore believe that the development that we have to attain in the society should be an inclusive development. We have to first develop the individual. By developing the individual, we will have to attain the development of the entire society as a whole. So this is what the economists are planning, and this is what Buddhism is doing, and this is what the science is also doing. So we have to look at, if we are developed as individuals, we must be happy and contented. So this is what the Buddhism teaches us. This is what the Vice Chancellor told us. If you are happy and if you are contented, then you will be able to make the society also happy and society also contented. So society's happiness therefore is dependent on what the individual should be attaining as their own end. So it will lead to social stability, where there is no any conflict among the people. Once people are in a stable situation, society is in a stable situation, you will have the social development. And the social development will provide opportunities for everyone to develop themselves. So this is what we are going to discuss today. So the ultimate goal of the society is therefore to develop individual. Through the development of the individual, the development of the society. And that development is not an exclusive development where only a single individual or a group of individuals should be developed, but it will be an inclusive development where the benefits of the development will be shared by all members of the society. So this is the ultimate goal of economics as well. So for a society to remain stable and remain progressive, there are certain prerequisites which have to be satisfied. And let us look at those prerequisites. And one is, we have to recognize and tolerate the individual differences. Even though each one of us who is present here is a human being, we know by physical capacity, by mental capacity, by brain capacity, we are different from each other. On top of that, with regard to the thinking pattern, with regard to the ideas that we uphold, we differ from each other very widely. So in a society where we have to have a stable and progressive development, we must have the tolerance and recognition of the individual differences of human beings. Then, once people have those differences, it is always necessary for us to have resolved those differences through peaceful means, without using violence. If we use violence, what we simply do is we try to impose our own will on another person, or we try to suppress his own free thinking life. So we will have to have a mechanism in the society to resolve all our differences peacefully without using violence. It therefore requires us to adopt a policy where we will not discriminate other people. Because you are a member of the clergy, you are a professor, you are a student, you are a person working in the central bank, or you belong to any other ethnic group, you should not discriminate other people. Any discrimination against any other person will immediately tarnish the social stability and the progressivity of the society. It therefore requires us to have an open approach to knowledge. Whatever we learn, we have to critically examine, we have to use our own intellectual power, we have to listen to other people. If other people have a better opinion than us, we will have to accept whatever they say, and we have to accept that we are. So we must have a very open approach, and the open approach requires us to look at everything in the society with an open mind, with an objective mind, without pre-biases or pre-prejudices. This is the most important requirement for a progressive and a stable society. There, again, another aspect that we have to respect is we have to accept that everyone has a right to live. To enable everyone to have a right to live, we have to have a rule of law and the law for that in the society. So this is what we basically think as development and the prerequisite for development. Then if you look at the similarity and the differences between Buddhism and science, the main difference between Buddhism and science is that Buddhism tries to learn the ultimate truth. And that truth is not knowable to us unless we go through a meditational practice as it was recommended to us by Vice Chancellor in the previous session. We are not in a position to know the ultimate truth. What the science tries to do is to, by using a scientific method which was described in detail by Professor Tantrigoda. By adopting an objective approach, we try to find a truth. Out of the ultimate truth, the science tries to find a truth. So all what the scientists, even economists who have so far done is, they have found a truth, whereas a religion like Buddhism is trying to find the ultimate truth, which is the overall truth in the universe. So this is the main difference. So if anyone says that Buddhism is compatible to science, he doesn't either know science or he doesn't know Buddhism. So that's a big difference. And the scientists are finding a truth every day, and that truth is being refuted by other scientists every day. So what we find is that a series of truths being discovered by scientists, a series of truths being refuted by other scientists, and as a result, we are not in a position to reach the ultimate truth through science. The ultimate truth has to be found by following a religion like Buddhism, and there is a different approach to it. But there are similarities between the two, science and Buddhism. Both cherish free and objective inquiry. Buddhism doesn't recommend us to have a pre-biases or pre-prejudices. If you want to analyze something, we will have to have an objective analysis, and then only we will have to accept whatever it is true, and science also tells us the same. Therefore, both Buddhism and science will frown upon prejudices and biases. They both uphold reasoning and free thinking. Buddha is one of the foremost religious founders who had always advocated for the free thinking and reasoning. Both value critical analysis before accepting any idea or any idea, and both tolerate opposite views. Now Buddhism, unlike other religions, has a unique feature because one of the Nobel Prize laureates in economics, Amartya said, he has written two books. One is Argumentative Religion, the other one is Identity and Violence. In both books, he has in fact praised Buddhism as one of the only religion in the world which has a history of free discussion, free tolerance, acceptance of opposite views, and having done that, whatever the original ideas that you are having, you will refute. The Buddhist councils which we had in India, starting from 5th century BC, all these Buddhist councils were in fact free discussion forums. At this forum, people can debate, people can analyze, people can disagree, people can agree, and by doing that, you will try to find the truth because you have no prejudices or biases. So this is one of the unique features which Buddhism has. You might not agree with the other person, but you have to allow the other person to express his view freely. You must open yourself to discussion. Having had that open discussion, you must either accept or reject whatever he says. But if you do so without doing that, it's against Buddhism and it's against the scientific approach as well. So as I told you earlier, the ultimate goal of Buddhism is to find a way to reach the ultimate truth, and the aim of science is to reach a truth. And the science can never reach the ultimate truth, and it can reach a truth. But we find there are certain modern trends which have been responsible for a convergence between Buddhism and science. Buddhism is an ethical way. Buddhism always has a heart. And Venerable Dr. Piyananda told us by quoting various sutras, whatever that we do unless we are guided by the moral and ethical principles, we cannot be contented. And science did not have a heart. Throughout its history, it didn't have a heart. It was an objective analysis. In the objective analysis, you cannot have prejudices and biases, and you cannot allow your own emotions to overrule your decision-making process. But today, we find that science is also thinking of developing a heart. Before this session, I had a long discussion with Professor Nalin before we came for the session. He was talking to me that in health science, it is essential today to look at the delivery of health services from an ethical point of view. Because in the delivery of health services, he has found a lot of immoral and unethical developments have taken place. So what he says when he says that the medical science will have to have a medical delivery through an ethical principle, he is talking about the heart. Getting a heart from the science, getting the heart from medical science. So we today increasingly see that science is going to get a heart. So that is why economists are talking about global warming. They talk about the poverty, they talk about the exclusiveness in development. They talk about the disparity in resource allocation. They talk about the developed countries using more resources than the poor countries, just like the way keynote addresser Professor Wijewardena mentioned in his keynote address. So these things have, in fact, given us a new vista for economic development. Economic development without a heart is not a complete development, because if you look at it purely from an objective point of view, we will not making a contented and happy society. The modern technology on which the development has taken place is based on science. It's not the religion which has given birth to modern technology, the science, the world, the scientific principles. Professor Tantrigoda took pains in explaining to us various types of scientific principles which had evolved over the time, which have given us today our modern technology. And economic development is based on that. So, what we therefore see is, even though science tries to discover a truth in the world, there appears to be a convergence between Buddhism and science. It's not Buddhism is compatible with science. The science is going to be compatible with Buddhism. Because from the objective analysis of scientific approach, the science is going to develop a heart, and through the heart, the science is trying to build up a society where people are happy and contented. Because the scientists as well as economists have been blamed for all the ills in today's society, because they have been making recommendations without the heart, with their heart. But if you look at Buddhism and the free market economic system on which the modern economic development is based, we find both are consistent with each other in a number of respects. Buddhism also recognizes key to development is hard work. You cannot attain Nibbana unless you work hard and relentlessly. Similarly, you cannot attain economic development or individual development unless you work hard. So the hard work is essential. So both uphold the need for hard work. Both, in fact, talk about the need for resource conservation today, because we know all the non-renewable resources that we have in the world are going to be exhausted one day. Once those resources are exhausted, probably the new science and technology will be able to discover new resources, but it will take time. And the present population will not be able to adjust itself to the changing pattern of the new resources. And there will be a lot of heart, lot of agony, lot of heart pain, lot of frustrations in the society, which will lead to instability in the society. So both therefore talk about the need for resource conservation. Buddhism is one of the religions where it has happened, and in one of the in the Dhammapada Katha, I think Venerable Ananda was given some 500 robes by Sama, the queen of Delhi. He was criticized for getting those robes, and then he said, I have got these robes, but I am going to give the robes which I am wearing to other priests. Then he was asked, what do those priests do? They will give their robes to other priests. Likewise, what Venerable Ananda was teaching us was recycle resources. Instead of wasting, instead of throwing out, to recycle. And both economists and Buddhism therefore recommend that we have to conserve the resources. And both uphold individual innovation and development. And good governance, equity and fairness in whatever we do. Therefore, there are consistencies in both Buddhism and free market economy. Even though free market economy is a way of attaining material well-being of the society, whereas Buddhism is attaining the perfect development of an individual, the ultimate goal of enjoying the material well-being is also to enjoy one day the perfection of the individual and the society. So Buddhism is a development of a self-realized individual who would contribute to the society's sustainability. And what we mean by development today is the society's development through perfect development of individuals. Again, as I mentioned to you, we will one day develop a contented and happy society. So this is the end of my presentation, and thank you very much for inviting me to do. Thank you.
Thank you very much, Mr. Jayewardenepura, for that very beautifully argued pieces on development, Buddhist perspective. Now we finally have a person who is going to synthesize Buddhism, science and development using the presentations made before and also presenting his own thoughts. He is Professor Nalin Silva, who is the Dean of the Faculty of Sciences and Professor of Mathematics at the University of Kelaniya. I don't think he is a stranger to any one of us. He is I would describe him as a scientist philosopher who has, I think, rekindled an interest in national and traditional thinking or knowledge for the world, for development. I would ask Nalin to make his presentation.
Thank you, Narada, for introducing me. And Venerable sirs, distinguished members of the panel, the Vice Chancellor, the Deans and the other academics, my dear colleagues. I am honored to be here on this day when you, together with us, celebrate the 50th anniversary of, I would say, imposing a Western university structure on the two periods we had, which were already universities in their own sense. I must say at the very beginning, when I left home in the morning, my wife said, "Don't be controversial." But then she also knows that I cannot be but controversial. So in other words, she wanted me to cease her to be a husband, at least for this afternoon. But unfortunately, I am not interested in that because I need her simply because I will be retiring in about 9 months, and without a very fat provident fund, I had to depend on her salary as well as the professional. As I did for 10 long years before I joined Kelaniya. Now, I have been entrusted with this task of comparing or synthesizing what the previous speaker said. Now, there are two ways of doing it. Either I can say that they were very good teachers and not be controversial and leave the place. So to begin with, I will say, okay, they were good teachers and there were certain things common and also certain things I would agree. For example, Wijewardena said how Buddhism can be used in secular life. In fact, Buddha did not preach his Dhamma only for bhikkhus. He mainly preached for the lay people. So it's secular. And I was a bit surprised to hear that in USA, some 300,000 or 3 million. 3 million Jews are Buddhists. And that's out of 6 million. Okay. Now, I was surprised because this may not augur well for Buddhism. Because, in my opinion, well, as most of us are Buddhists, and I suppose we would like to have many Buddhists in the world, but unfortunately, Jews are not the ideal specimen to become Buddhist. For the simple reason that Jews are very abstract in their thinking. And they are the people who created, I would say, abstract thinking long before the Greeks introduced the axiomatic system in mathematics and other sciences that were practiced during that time. What would happen is that Buddhism also could end up as an abstract theory. These gave that people like Einstein, Feynman, not Heisenberg, but all these people, most of the reasons. And also Marx, Engels, not taking Marx, Trotsky, they were all used. I am with them because I also like abstract thinking, otherwise I wouldn't have mathematics. But at the same time, I know the dangers of having too much abstractness in our day-to-day life. Professor Tantrigoda talked about the philosophy or this epistemological background of modern physics. And what he said was that modern physics, after the creation of quantum mechanics, cannot be objective. Quantum mechanics is not an objective science. It depends on the observer. It talks of observer-dependent rules and results, and they are all, well, I would say creations of mind, but they are relative to the mind. It's the observer who measures something and gives us a value for certain measure. It's not that the measurement is there long before the observer tries to measure it. For example, in classical physics, you measure the velocity of the speed of a bus. Whether you measure the speed of the bus or not, the bus has a speed. Whereas in quantum mechanics, unless you measure the speed of the bus does not have a speed. It's very strange. But you have to measure, and also before you measure it, you will know what the answer is going to be. All that you can say is that it has certain probability of getting certain value. And also, once the speed or the movement of user observer is measured, the position is not known. It can be anywhere, everywhere. Only after you measure the position or try to find the position, the particle begins to have a position, not before that. Before that, what you can say is that there is certain probability that the particle will be found here or there if it is measured. Measured is that you try to find out where the particle is. Now, that is one of the things that I was interested in. Because that's one of the things that made me to think about science from a different perspective. I was also a Marxist, as Nalin knows, and a physicist, or let me say a theoretical physicist, because I am not very good in my practicals. But after I studied quantum mechanics and went on studying further, I began to realize that there was something wrong with science. In fact, with the entire ABB that had been built by the scientists. Now, Dr. Wijewardena. Dr. Wijewardena talked of economics and Buddhism. I beg to differ when he said that science is objective and Buddhism is objective in the sense that we try to find out an ultimate truth, whereas in sciences we try to find out a truth, a series of truths, maybe. But let me illustrate this by an example. Whether we are seeking truth in science, I don't think that the scientists are interested in truth as such. What they are interested is in creating stories that will fit certain observations and may be consistent with observations. The example I had in mind was Newton's theory of gravitation. We all know something about Newton's theory of gravitation. Now it is said that all these things fall to the ground, objects fall to the ground, because of the gravitational field or gravitational force exerted by the earth on these particles or objects like atoms. Now that had been the dominant idea in physics for more than 250 years until Einstein came around and said, no, that is not the way or that is not the reason why these bodies fall to the ground. He gave a different theory or different. Well, I would say he created a different story. Very good story, better than a bedtime story of course, but we could listen to it. And also, he was able to explain all these phenomena using a different concept altogether. According to him, it is real, according to him, there is no gravitational force. It's not Nalin who says that there is no gravitational force. If I said nobody would have listened to it. But it's great Einstein, Albert Einstein, the Jew, who is German Jew, who said this. In 1915, nearly 100 years ago, according to him, bodies fall because due to the curvature of space-time. Now, curvature of space-time is not a concept that can be compared with the gravitational theory. They are totally different. And if I may use a technical word, they are incommensurable. according to people like Thomas Kuhn and Paramat, who are supposed to be philosophers of science. They are not compatible, they are incompatible places. So the question is whether they are truths, both. Are they truths? If one is a truth, the other cannot be a truth. They are not even relative truths. They are only stories that have been created to explain this phenomenon of falling for these two sounds. That's all. In about 100 years' time, maybe another person, hopefully a Sri Lankan, would come up with another story that bodies fall to the ground, roots are the next. I have, when I go to school, I ask children, why did the coconuts fall to the ground? Fall batting, Mama dear, fall batting, fall garden. Also consistent theory. Even though it's confined to coconuts. Coconuts fall to be state. Okay, now just leave that. Let's come to the main topic. Buddhism, science and development. Now when you say Buddhism, science and development, it is already loaded with ideas. You think that there is one Buddhism. There is only one science and one development. I would ask, what are we trying to compare? Which Buddhism, which science and which development? Whose Buddhism, whose science and whose development? If there is, no, these topics are also dangerous sometimes. Because it gives the wrong meaning. And it gives you and they condition you, and even though we may talk of open mindedness and various other things, that you have free thinkers, whatnot, but sometimes our thinking is closed, and in fact the topics close our thinking very often. What is the Buddhism that we are talking about? This is Buddha's Buddhism. Now, how I will find out Buddha's Buddhism? What we have in Sri Lanka is mainly the Buddhism that we got from, inherited from the third council, the third Sangaya. And of course, that has been covered from. It has been decorated with certain other ideas. It's not only the third council Buddhism that we have, it's also covered with our Jaksha and other traditions that we have here in Sri Lanka. So we are now here, even though we don't say so, we have in our mind the similar Buddhism that we practice here. As of course, when I say similar Buddhism, I am not using that in the sense of the another way, definitely not. I use similar Buddhism in the sense that the Buddhism that was introduced by Wijewardena, the Buddhism that we have inherited from the third council, and also the Buddhism that has been decorated, I might say, with other ideas. Now, however much we try, we cannot get rid of the system board category. Whatever the Buddha has said, whatever the certain discourse say about the gods, not God, we cannot get rid of these gods. That's in our tradition. Vibhishanas, Vishnu, Saman, all will be there for another 2500. Now, so you can see that there is no one Buddhism. There are Buddhisms. And of course we think that our Buddhism is the Buddhism. But I must say that I am with the similar Buddhism or the Jayewardenepura Buddhism as practiced in Sri Lanka by mainly the similar people. Then what about science? We think of, from that is the most dangerous. At least in Buddhism, we know there are Mahayana Buddhism, Tantrigoda, Hinayana, Theravada, Sarasvati, various Wijewardena, various sects. But when it comes to science, we think that there is only one science. And in the universities, we have faculties of science, of one of which I am supposed to be or reluctantly that. And faculties of medicine. But we never say that what we have here in the universities are faculties of Western medicine and faculties of Western science. Does any one of us teach any science other than Western science in the science faculties? Well, I tried to do that in the Kelaniya and I was chased out. Fortunately at Kelaniya, I am not being chased out for simple reason. The former vice chancellor happened to be very my father. Now, what is this science we are talking about? Is the science that has been created and not only during the last 500 years, but it's being created even at present. How many of us teach Wijewardana's theory or Silva's theorem when we go to the classroom? None of us. Simply because there is no Silva's theorem or Wijewardana's theory in science. We may be doing research,